Today we're doing the calculations for the heat of fusion of ice lab. Let's review what you did in your procedure. So you took a calorimeter, which was basically a styrofoam cup. Inside this cup you put some hot water. So this is very hot water. And then into that hot water you dropped several ice cubes. So of course these ice cubes are going to melt. And then what happens is the water went up in level in proportion to the amount of ice cubes that melted. So you had an initial amount of hot water, and I'm going to give you some sample data. So let's suppose this hot water was at 68.3 degrees Celsius, and let's say that you had 98.2 milliliters of hot water. Okay? Then at the end, what you did is you measured the total water, and the total water, let's say, was 158.5 milliliters. And let's say that the final temperature of the whole thing was 9.8 degrees Celsius. That was the final temperature. Okay, so we'll write down our data. The initial temperature we said was 68.3 degrees Celsius. The final temperature we said was 9.8 degrees Celsius. The volume of water initially, the hot water, was 98.2 milliliters, and the final volume that you recorded was 158.5 milliliters. Now, to understand this lab, let's take a look at the heating curve of water. We've been working with this already. So you've got this drawing, this is 0, and this is 100. So you took hot water. The hot water was at 68.3 degrees, so it was roughly over here. Okay? And that water cooled to a final temperature of 9.8 degrees Celsius. So this was 9.8 degrees Celsius, and my starting temperature was 68.3 degrees Celsius. Now the ice cubes were already starting to melt, so that means they were already at 0. And then what happened is these ice cubes melted and then heated up to 9.8. Okay, whereas the water that was hot only cooled off from 68.3 to 9.8. So you see that there are really three portions of this graph that we need to address. We need to address the ice melting. We need to address the melted ice heating up a little bit, and then we need to address the hot water cooling off. And what you're going to notice is that the sum of this heat that was absorbed by the ice is the same as the heat that was given up by the hot water. So if you understand that, you'll understand this whole lab. So this part, remember, is just an MC of the ice melting. This part is an MC delta T of the ice heating up that was already melted. And then this is an MC delta T of the hot water as it cooled off. So if you can understand that, all you do is set the blue equal to the red. So that's what's going to happen down here in our calculations. Okay, so you're going to have the ice melting is here. You're going to have the melted ice heating up is here. And then you're going to have the hot water cooling off, which is here. Okay, so this is the hot water on this side, and then this is the ice and the melted ice on this side. All right, so you already know how much ice you had in this case because you're going to subtract the amount of water that you had in the initial minus the final water. So when you do that, you're going to find out that the mass of the melted ice was 60.3. So this is going to be, I'll show you the calculations here. It's going to be 158.5 minus the 98.2, which was the hot water. And that's going to give you how much ice melted, which is 60.3. All right, now you need to find out, so that's going to be your M right here. So this is 60.3, and then this is also 60.3. All right, we don't know the heat of fusion of ice. That's the whole point of this lab. We're trying to find that. Now, we already know that 4.18 joules per gram degree Celsius is the C value for zone 3, and then now we need to know the delta T of the melted ice. So let's look back at our drawing. The ice went from 0 to 9.8. So that's a difference of 9.8. So you do need to show that calculation. So you're basically going to write 9.8 degrees Celsius minus 0. That's going to equal 9.8. So that's the delta T of the ice that heated up. So I'm going to write that over here. 9.8 degrees Celsius. Okay, so now we have the left side of the equation. We're going to add these two together to get the right side. And the right side is going to be the MC delta T of the hot water. So the hot water was 98.2. That's what you started with in my data. Again, the C value for that zone is 4.18 joules per grand degree Celsius. And now we need to show the delta T of the warm water. Well, if you look back at our graph, you'll see that the warm water started at 68.3 and went down to 9.8. So show that calculation, 68.3 minus 9.8, and that's going to tell you the hot water's delta T, which is 58.5 degrees Celsius, and that's what I'm going to write over here, 58.5. Oops. 58.5 degrees Celsius. Now you're just going to do a bunch of algebra. Okay, so let me just highlight that for you. You're going to have an equation where you have this and your x's right here. Then you're going to get this number in blue, and you're going to get this number in red. If you want to get the x by itself, you first have to get rid of this off of the side. So since it's being added, you need to subtract the blue here from the red there. So this red minus that blue. And then you're going to have a big number, whatever that is over here, and then you're going to have 60.3 times x equals the right side, so you have to divide each side by 60.3 to get just the x by itself, and you're going to find your C value of the heat of fusion of ice for your lab. Now the real value is supposed to be 334, so hopefully you're pretty close, and what you need to do then is find your percent error by taking the theoretical, which is 334, minus your actual, which is this number, divided by absolute value of that, of course, divided by 334 times 100, and you're going to find your percent error. And you're going to do that for both your trials of this lab. Okay, so you see the calculations down here.